Okay, well, good morning, and thank you for joining our webinar today on the topic of Strategic Asset Manager's Guide to Pavement. These are best practices for extending pavement life and optimizing your pavement maintenance budget. So the intended audience for this talk is property owners, asset managers, facility owners, anybody that interacts either in an ownership role or in a management role of maintaining your property's pavement. And just a quick note that I will be sharing a recording of this after we conclude. Encourage you to share this with other colleagues in your offices that you think might find this valuable. I guess I will say that we've been in business for 25 years, as you see on our logo there. And most people tend to reach out to us when they have a problem. Either a pothole has manifested or they have severe alligatoring. And what you're going to learn today is really that this is kind of the backwards approach to get the best bang for your dollars. We call that a worst first strategy, which is always going to be the most expensive. So we'll talk about some other paradigms outside of pavement where that's true, but it really boils down to the old adage of an ounce of prevention is worth a pound of cure. We're going to see that in spades as we go through the curriculum today. In terms of credentials, I did want to just mention briefly, as I did, that we've been in business for 25 years. And I kind of joke that when I was dating, who's now my wife, 18 or 20 years ago, she was in the tree care business. And she was always looking up into the trees, up into the clouds, kind of optimistic mentality. And I was always looking down at the ground, looking at pavements. So that was kind of our joke as we were dating. I guess the reason I mention that is that I have been spending a quarter century looking at pavements. So just a lot of wisdom looking at jobs that we've done decades ago, looking at things that other contractors have done. In addition to that, our company has attended more than a dozen conventions at the National Pavement Expo. I've actually been a speaker at that once upon a time. And so a lot of the curriculum from this talk comes from their partner, which is the Asphalt Institute in Lexington, Kentucky. They've been, from an engineering perspective, studying pavements and pavement construction, best practices, pavement defects for over 100 years. And so most of the credit for this talk is due to them, and we've seen it play out in real life as we've conducted our business. So ultimately, the goal in the next 30 minutes, I want to be able to impart to you 25 years of wisdom and hopefully help you steward your budgets in the best way, because there truly are thousands, tens of thousands, potentially hundreds of thousands of dollars or more at stake, depending on the size of your portfolio. Pavements are not cheap to install. They're getting more and more expensive with inflationary pressures and so forth. There's new stormwater implications in Washington State that have come down the line in the last few decades, which can even further balloon the cost of pavement because you might be triggering stormwater upgrades, which if we had prevented the pavement defects in the first place, we could have avoided all those things. So away we go. I think the most logical place to start is to understand how pavements are built. Ultimately, pavement defects are going to manifest themselves at the surface, but it's oftentimes much more complicated than that. Pavements fail for a variety of reasons. It may or may not be the pavement that's the issue. So we really think about the subbase, the base, and then the asphalt, which is the wearing course at the top. And all conditions are not created equal. We can really be fighting the native conditions if we're trying to build a pavement on top of what was maybe a floodplain or a wetland, or if it's on the side of a hill, those areas tend to have a lot more problems. Meanwhile, we could be building something that's a very good native subbase. So all these things go into how we think about how the pavement should be constructed ultimately, which if you have an existing pavement, that might have been done long ago or decades ago, and that decision is out of your hands. But we still think about the subbase, the base, and then ultimately the wearing course in terms of how we evaluate and how we want to remedy pavement maintenance solutions based on what we see at the surface. So as it says there, the stability of the foundation dictates everything above. If we have a bad subbase, we're going to want to engineer things above that in a different way. We then have our crushed rock base course, which depending on the circumstances, we're going to, something for a walking path is going to be thought about and engineered entirely differently than something that's going to need to accommodate, heavy truck and trailer traffic all day, every day. We're going to need a different type of rock potentially in that base course. We're going to need a thicker base course, and then we're also going to need a thicker and potentially different engineered asphalt course at the top. So this will sort of serve as the backdrop as we talk through some of the other details on the subsequent slides. So here's where you see that in reality. This is a roadway near our office that we did almost 20 years ago now. You see this is basically a new roadway that's getting prepped for paving. So the native subgrade is underneath here. We're looking at the crushed rock, which was properly placed and then also compacted. Getting good compaction on your subbase is hugely critical. So vibratory rollers had gone over this to prep it for paving. Next step is that we actually lay down the hot mix asphalt course. So what I want to particularly point out on this slide is that the width of a paver can only go to certain widths. Even the largest freeway pavers generally can only swing out to 20 feet, give or take. So these passes were probably in like the 12 to 14 width category. And just during the course of pavement construction, we're always going to have what are called cold joints in the construction. These are an unavoidable part of the construction process. Ideally, the pavement passes are done in quick sequence, so you have less of a true cold joint and you can have more of a warm joint. So if you think about like kneading bread together, you want to have one uniform final product that's interlocked and cohesive with itself. So to the extent that these can be done in quick succession and you have good techniques in terms of roller patterns, you can minimize the weakness of this cold joint, but all pavements are going to have cold joints, at least in some places. So as we go to the next slide, the red arrow here is pointing where that cold joint is. So after the second paver pole goes through, you can still see that visually of where that was constructed. So these cold or warm joints are always going to be the weakest part of a pavement. And sometimes this road is actually built with a crown in the middle, so the water is designed to flow towards the curb and gutter at the side. But some pavements are designed the opposite of a crown, which is a valley, where the water is going to essentially be flowing to the weakest point. So most parking lots are constructed that way with catch basins in the flow lines at the lowest points. They're really architected for the water to go to the weakest point, which is something we want to be keenly aware of as we think about maintenance issues and maintenance dollars. So here's a bit of a visual of how pavement defects are going to manifest themselves. At some point over the first handful of years, maybe it's at year 3, maybe it's at year 5, or maybe it's at year 10, there will begin to form small cracks in the pavement. And then in subsequent years, you're going to start to get moisture penetration in through that crack. And this is where we really want to be thinking about how a nurse would approach triage, right? We want to get a Band-Aid on this as soon as possible to try to prevent subsequent damage. And this is where we see a lot of maintenance issues are overlooked, and this is where that ounce of prevention is going to prevent a lot more expensive, costly repairs. So what happens is the water gets through that asphalt layer and eventually it's going to get into the base course layer here. Obviously the base course is gravel, it's not asphalt, so it's going to be more prone to erosion. So the water gets in there, starts to erode what are called fines. So you have the firm aggregate, and then you have smaller aggregate, and you have more like sand material. That's why it's called a minus. 5/8 minus is a very common subbase material. So as that water gets under there, then it further weakens the base course, and then you add a load on top, either a car or a dump truck or semi-truck, garbage truck. You no longer have the support needed from the subbase layer to hold that pavement up. So again, if this were to happen on a walking path, you're probably not going to see the same sorts of damage as you are in a parking lot, or even like thinking of a shipping receiving facility that has lots of heavy traffic going over all the time. The weight of the load is really going to exacerbate the problem once that moisture penetrates through. And then ultimately, it's going to get worse and worse. You'll get what's called an alligatoring effect, which we'll show you here shortly, or in the most severe cases, potholes. This is where most people call us, is at the step 3 and step 4. And as we'll talk, we really want to be having good conversations during step 1 and step 2 to prevent this in the first place and save tons of money. So here are some real-world visuals of what we just talked about. So I don't know how old this pavement is. This is at our local outlet mall up the road from our main office. Initially, you're going to see a single hairline crack that goes up that flow line. And again, you see these are right next to catch basins, right? So the water is engineered to flow towards these catch basins. The net effect is that we have lots of water rushing directly to this crack, which is a bad thing to have. What eventually will happen is that single hairline crack is going to start to feather and fan out, as you see here in the first picture, and then it's going to progressively get a little worse, right? After another 6, 12, 18 months, it's going to get worse. Then it's going to get worse yet, eventually becoming what we call true alligatoring. So we can't really do any preventative maintenance at this point anymore. Now we're in a reactionary mode, and we've gone from plus or minus $1 a foot to do crack filling to probably several $1,000s of rehabilitation that we have to now cut this out and repair it. This final picture here, it's gotten even worse. And this is the most extreme case, covered a little bit by dirt and sediment, but you can see this entire road is essentially alligatored. So it might have taken 5 years, 10 years, 15 years for this entire process to play out, but there was likely zero prevention done, and this entire investment is essentially lost at this point. We can't do anything to prevent this. The only remedy at this point is to tear it out and pay lots of money to replace it completely. So in terms of just a visual illustration of this, I like to think about paradigms outside of pavement, because there's, just as a homeowner, I see some of these things, thinking about moisture on your home, on your siding and your paint. We obviously have moisture barriers underneath our siding, and then we have siding, and then we have caulking, and then we have paint. Well, if you've ever experienced a water problem at your house, water always finds a way to get to the place you least want it. So once it infiltrates, it's going to take on a mind of its own and get to places that are not good news. So in the siding example, like if we let our caulking in and around our windows or on our siding, if that starts to fail, which is a very cheap thing to replace, if that fails, then the water gets behind the siding, gets into the framing of our building, into the insulation potentially, not what we want. So in the paradigm of asphalt, we really want to use these cheap methods of preventative maintenance where things are still cheap: crack filling, seal coating, maybe it's minor patching. As we get into mill and overlays and extensive patching, we see the cost is going to escalate. And then if we get to this point on our last slide where we're having to do full reconstruction, then things get very expensive. We're not only potentially having to replace the asphalt pavement surface, but we might have to do some rehabilitation to the sub-base as well. We want to be spending maintenance dollars when we're in the prevention mode, not when we're in the reactionary mode. As it relates to our home, we want to be doing a periodic assessment of our caulk, and we want to do regular painting. We do not want to be tearing off and replacing siding, or worse, getting into the plywood that might be behind the siding. Those are very expensive remedies, and the same holds true in the pavement space as well. So just to underscore this, what can go bad? We don't want to be firefighting and reacting to problems. We don't want to be having a philosophy that's driven by complaints, emergencies, urgent things that are reactionary. Ideally, we have a planned schedule. We're doing cheap things that are keeping our good pavement in good shape. We want to ideally get the benefit of curb appeal as well, and ultimately have predictable and stable and low budgets, not reacting with high dollar reactionary things. So at the end of the day, we have a number of tools in our tool chest for pavement maintenance, from crack sealing, seal coating, patching and base repair, as we'll see in some subsequent slides. If we do need to get into some of these remedies, it is ultra important that we are assessing and fixing and recompacting our base before we put our new pavement back in. There is a time and place for overlays, either what's called a grind and overlay, which involves milling off part of the pavement surface, or we could do a complete full depth remove and replace. So the grind and overlay, if you've ever been on a freeway and you experience like the grooved pavement, that's exactly what a milling machine will accomplish. So getting into some details on each of these methods. So again, crack filling is a great remedy when we just have solitary cracks. They might be longitudinal or transverse in nature. So all that means is longitudinal is in the direction of that original paver pull. Transverse are cracks that can develop that are perpendicular to that initial paver pull. This is going to prevent cracks from widening. It's going to prevent potentially organic material like weeds from growing through. It's going to prolong the life of the pavement and delay the higher dollar remedies. What it can't do is it can't glue the pavement back together. It can't really fix structural problems. We're really trying to prevent structural problems. And it certainly is not a remedy for alligator cracking. So if we do get beyond the solitary cracks into more extensive alligatoring, it's really not appropriate for that. We've lost our window and we're past the point of no return where this cheap tool is effective. So some things that I like to point out, I really encourage people to assess their cracks every year, at least every 2 years, but ideally every year, because what's going to happen is we get freeze-thaw events, and we live in a climate with a lot of moisture. This crack was treated sometime in the past, maybe it was 1, 2, 3, 5 years ago, but just because we did it once doesn't mean that this is not going to open up again. So this crack filler has started to fade away, and this needs to be treated again. Similarly, asphalt patches that are conducted have a similar product called tar sealing that goes around the edge. This was a picture that I took in the street many years ago. I don't know if this was ever tar sealed. It could have been that it was forgotten by whatever contractor did this, or maybe it just eroded over time. But these are also areas that we want to assess and get refilled with either tar seal or crack filler, because this is a weak point that we're going to get moisture penetration on. The way crack filler is applied is either with an automated squeegee, which we utilize, or this is a hand method. We want the product to be flat or slightly recessed, and the reason for that is that we don't want it to be tracked, especially in hot conditions. We don't want a lot of excess material that's bulging out of the surface. Pavement repairs, so presuming we have damage that's beyond just a single crack, we are going to have to consider full depth repairs for things like what you see in the picture here. A common mistake that we see a lot of contractors do, and I think regrettably a lot of pavement owners get fooled into doing, is making the patches too small. So the guidance of the Asphalt Institute is to make any patch 12 to 18 inches larger on every side than what we see visibly at the surface. And the reason for that is that the damage actually starts in the subbase and it propagates upward, and we see it at the surface last. And I have some pictures in the subsequent slides that I'll show you kind of how that can happen. We want to certainly cut this out with a saw cut around the edge, excavate it completely down to the subbase, recompact the subbase material, and then put new pavement in. So as you can see here with the white outlines, the wrong way to go about this would be to just make a patch that's around the visible damage area. And what we really need to do is to go 12 to 18 inches beyond. It seems like we're spending more money now, but long-term, this is absolutely the right way to approach this. Because as you see over here, what's ultimately going to happen is we're going to have new damage that's outside of the limits of a recent patch. So this area over here was patched. It was not made large enough. And then we had new damage that happened just outside of it. And now what do, right? We don't want to just repair this, and we're going to start getting what's called a patchwork quilt effect. It's not the right way to go about things. What this contractor should have done is to repair in the appropriate size from the get-go. Okay, as we see on this slide, these are just some more best practices with how the patching should be conducted. So we want to make a clean saw cut around the edges. We want to get all the way down to our subbase. We want to get our new HMA material in there and compact either with a vibratory roller or a plate compactor. Moving on to the topic of asphalt overlays. So there will be a time and place where we want to consider either a straight overlay, a grind-in overlay, or a full depth remove and replace. We call that a mill and fill. So if the conditions of the pavement have gotten beyond things that we can remedy either with crack filling or patching, the overlay is an option. Oftentimes we will do not just one or the other, but we will do full depth patching in the worst areas that might be alligatoring, and then use an overlay in conjunction with that. One thing that we want to be mindful of with using overlays is a phenomenon called reflection cracking. If we make a strategic decision to not do a full depth remove and replace, we have to be mindful of the pattern and pervasiveness of any cracking. So as you can see in this roadway, there is some cracking here. So this is going to be prone to this concept of reflection cracking, which essentially what's going to happen, maybe it's 3 years, maybe it's 5 years down the road, these cracks are going to continue to propagate upward and reveal themselves in this new mat. This isn't necessarily right or wrong. It's a cost-benefit decision that we have to weigh. Maybe this owner of this road made the decision to try to get 5 years of lifespan out of this for a certain dollar, rather than trying to spend another budgetary dollar to try to get 20 years of life. So again, there are not necessarily always right or wrong answers. It's a question of what are the budget dollars that are available, and how can we value engineer those budget dollars over a time horizon that's important to whoever owns that parking lot, road, property, etc. So that's asphalt overlays. We also have seal coating. I do see that people overutilize seal coating or misuse it in situations where we are beyond prevention. Parking lots can have alligatoring that don't get remedied. Maybe they have crack filling that hasn't been remedied. So unless curb appeal is like the overwhelming motivation for doing seal coating, we will always recommend that people take care of crack filling first, because it's the cheapest and prevents the most subsequent maintenance dollars, taking care of asphalt patching next, and then if those things are taken care of, we will utilize seal coating as the next item in terms of priority order. Now, if you have a retail business and curb appeal is really important to you, like a restaurant, a hotel, perhaps an apartment complex, that's just, again, something to weigh in terms of a value proposition, in terms of how important is the structural benefits to you and how important are the cosmetic or the curb appeal or aesthetic elements of what we're doing to you. So there can be a time and place to, I guess, skip seal coating higher up the priority list if those things in particular are important. So some things beyond asphalt in particular, broken curbs can also be an area where moisture intrusion can be a problem. We can help with those. There are things related to liabilities to lawsuits. Certainly any place that somebody could trip and fall, so like the trip hazard that you see on the sidewalks, or maybe it's a pothole. Those are things that we can also help with. And then ultimately drainage are things that we want to take a very keen look at. As you can see, the picture on the right here has what we call a bird bath phenomenon right upstream from the drainage, so the water is not getting to its final destination properly. So those are things that we want to keep an eye out for and remedy as soon as possible as well. Onto the topic of extruded curbing. So just like asphalt needs a proper base to rest on, curbing does as well. So whomever installed this placed this extruded curbing directly onto dirt or gravel. That is not how this should be designed, and as you can see, probably cars bumped into this and slowly just pushed it off the gravel. We actually use a glue type of adhesive to glue the bottom of the curb to either asphalt or concrete, some sort of hard surface that's underneath it. We also want to use the right remedy for the right problem. So this Property owner had used extruded curbing as a way to effectively make like a wheel stop for cars so that they wouldn't advance too far into the adjacent stalls. And as you can see, this is just not the right product for the use case. What we want to use instead are what are called precast concrete wheel stops. These are made at a factory. They are made with ready mix concrete, not with extruded curb mix, so it's a different mix design. They're much stronger structurally and are intended for this use case. So you can see on this job that we did, we actually have a nice extruded curb here at the back, but then we used concrete, precast concrete wheel stops that are adhered with a pin to get the desired outcome for the bumper stop application. We also have something called a bull nose. So we see lots of properties that have damage from garbage trucks or other types of people cutting corners. So these areas are going to be hit with different types of forces. One thing we might want to consider is what's called a bull nose here. Other things that we do, what we could put here is what's called a bollard. So if you've seen at gas stations, you'll see them in and around the gas pumps, in and around ATM machines. They're the tall cylindrical items. They're called bollards. So we could use a bull nose in conjunction with a bollard right here at the corner that will just encourage people not to cut that corner, because they obviously will not want to hit that bollard. Just a few comments about drainage. So again, catch basins are designed specifically for water to flow there. We want to be keenly watching pavement defects in and around drainage structures because they are getting such a high volume of water. So a crack can very quickly turn into one of these other situations that we see. We've actually seen situations where this catch basin is actually sitting on top of a large piece of precast concrete under the ground. We've actually seen where the water has been so powerful that it's actually eroded the sidewall of the basin itself, like a couple feet under the ground, which then we're not just talking about a pavement repair. We're going to have to tear out the entire catch basin grate, lid, and the basin itself, which is a very costly repair. So encouragement to do like we've done in the bottom right corner here, to quickly fix any pavement defects in and around catch basins, because they are more likely to expand in scale and scope very quickly. A quick just anecdote about a study that was done on a property in California, and this just kind of underscores the ounce of prevention philosophy that we talked at the outset. There's actually a study where a property owner could have spent about $7,500 over the course of 4 years doing crack filling and small repairs, and they actually neglected those things, and 4 years later they had very costly repairs in the form of large patches, sub-base rehabilitation. So back to the slide earlier on about just showing the exponential nature of pavement defects. This is what we want to try to help you avoid, is being more proactive, not reactionary. And again, just this idea of worst first. If we can be more strategic and be thinking more in terms of 3, 5, 10-year time horizons, rather than just trying to address things once we see problems, that's always going to be more expensive. So in terms of, I guess, our advice to help you make some preliminary first steps towards getting a strategic plan in place. If we think about like a 3-year budget horizon, doing assessments, and our team is on call to help you do this at your various properties, really flipping that worst first paradigm on its head. And if we have things that are alligatoring today, they're probably not going to be a lot more alligatoring next year, right? They're going to be more alligator in 5 years for sure. But what we should, if we have limited dollars and we can't do everything on our list today, we should definitely, in year 1, try to crack fill everything that is still in relatively good shape. So preventing the cheap stuff from becoming moderate or more expensive is going to be a much better use of limited dollars rather than trying to go out and do all the worst stuff first. That's really our encouragement. And again, every situation is different based on whether you have foot traffic, whether you have car traffic, whether you have industrial types of traffic. So these rules should be kept with that in mind, that there's a right remedy for the right situation. And budgets are different too, right? If you have the budget dollars to hit everything on your list, by all means, make that happen. But we've found that this is the best way to prioritize things in order by flipping the paradigm on its head. And as we get close to conclusion here, I've accumulated a folder on my computer over many years called Stupid Asphalt Repairs. These are things that I've seen out in the world that drive me crazy. In the top left corner, we see somebody trying to use crack filler for alligatoring. It's just a waste of effort, a waste of money. We're not solving anything by putting crack filler into this area. Patchwork quilts, I alluded to that earlier. So this started as one patch. There's actually some damage here on the leading edge you can see, which is already developed. We have another patch up here, and then there's a third patch. I don't know what's beyond the frame of view there, but this is absolutely not what we want to do. Lipstick on a pig. Don't get scammed into things like this. This is essentially like a paper thin overlay to try to fool somebody that they're getting something of value. This is going to quickly flake and peel off. What we need to do is do a proper saw cut, remove the material. Really, the rule of thumb too is that any pavement thickness should always be 3 times the size of the maximum aggregate size. So most of our pavements are what's called 1/2 inch HMA. So the 1/2 inch is the largest aggregate in that mix, which means that the minimum thickness of any pavement, either full depth pavement or overlay, would be 3 times that, which is 1.5 inches. Sometimes we use a 3/8 aggregate, which is called a modified B. 3/8 times 3 would be 9/8, so just over 1 inch. So in no circumstance are we ever wanting to be putting down like a 1/4 inch of asphalt mix. This is just not a good practice. This one down at the bottom, so we see like all this silty type of material here. This is actually a project that was on the side of a hill. And against our advice, our customer wanted us to continue to come out every 2 years to patch this asphalt, despite our explanation that this really was not an asphalt problem, it's a base problem. It's on the side of a hill. It's basically like clay underneath their property. The proper remedy for this would be to like dig out the sub base probably to like 24 inches and put like a big material like quarry spalls in for like the first foot, and then put like a clean crushed material, maybe a 1 inch or 1.5 inch crushed material, clean crush for like the next 6 inches, and then have like a 5/8 material directly underneath the pavement. So trying to use pavement to remedy something that's really a foot or 2 down is not going to yield a good outcome. Another example, I have no idea what was going on when whomever did this project engineered it, but they basically did a grind and overlay in this lane of travel, and they did a grind and overlay in this lane of travel, and they left all this damage right in the middle. And then finally, this is a seal coat application. You can see whomever did this did a pretty good job applying. This is probably a couple years in the rearview mirror that this got done before the picture was taken. But the area over here was applied properly, and obviously something happened over here, and it did not get a consistent application. So just some things to be asking questions about from whomever you decide to hire as your contractor, to make sure that you are getting a scope of work that makes sense for your circumstances. In summary, we want to be thinking about how we keep water out. How do we plan out proactively? Let's diagnose the problem before we come up with the right remedy, and then ultimately choose an expert partner. We're hoping that Rainier Asphalt and Concrete will be your chosen partner. We can do it all. We do all these things in-house. We have 3 locations up and down the I-5 corridor in Pierce, King, and Snohomish County, and we look forward to talking with you further.